Hello everyone, welcome to Data Structures Lab. In last two videos, we have seen array implementation of stack and queues. In this video, we are going to see how to implement linked list. Linked list is a data structure for which the elements can be stored in the non-contiguous memory locations. Since here the size is also not fixed, we can add element anytime and anywhere in the list. The only restriction with the linked list is that it does not allow random access of the elements like you have in arrays. The elements in the linked list can be accessed in the sequential manner only. So while implementing linked list, we need to understand that here every element would be called as a node. A node is comprised of basically two parts, a data part, which is also called as an info part, and a pointer part, and this is nothing but the pointer to the next node. So left part is basically used to store the data and right part is basically used to address the next node. And hence we can traverse through the list sequentially. And that is why I have taken this structure node for defining a node in a linked list. So every time whenever you want to have a new element in the linked list, we will be creating a new node into this linked list. So starting with the program, if we go ahead, I have defined certain functions I have declared certain functions such as create, display, inserting node at the beginning, inserting node at the end, inserting node at a particular position given by the user, delete a node at the beginning, delete a node at the end, and deleting a node at a specified position. Now these operations are being implemented for the singly linked list over here, because we will be having only one pointer which is pointing to the next node, so we can traverse in a single direction. So initially whenever we are creating a linked list, obviously we need a pointer through which we can traverse. So we have taken a start pointer which is initially null because we haven't created any node over here right now. I have given a switch case or the here for going through the different functions such as create, display and so on. So different options are given, case 1, 2, 3 and so on for the different functions. Let's go ahead with the create function of the linked list. How to create a linked list? To create a linked list, this statement is simply allocating the size for the particular node as we have defined the structure node over here. So if the space is not available, we are simply saying that the space is not available, that is out of the memory space. And if it is available, then we will ask the user to enter the value, and that value would be taken into info part or the data part of the node. And then we have to set the next pointer. Now this would be the first node if the linked list is empty, or it would not be. If it is so we can check it using a condition. If start is equal to null, that is start is pointing to null, indicates there is no node in the linked list. In that case, whichever new node you have created, that would be the first node and hence your start would point over there. And if it is not the first node, in that case we can simply take a pointer which will take the position of start, and then we will get the last position where we can insert this particular node, and accordingly we can move on the pointer. Okay, and at the end, as we know, that particular node which we have created would be the last node. Okay, so till that node you will be checking if the pointer part or the next part is equal to null, you are moving to the last node. And in such case, if it is not there, you are simply incrementing pointer using the next part of every node. Okay, and once you have got it, you are going to fix your new node over there. The second function is display function. Display function is to simply display the nodes of the linked list. So you are going to start with the start pointer. If start pointer is null, indicates there is no node in the linked list. So you can simply print a message, linked list is empty. And if it is not the case, then you can take a pointer, and obviously the last node would be pointed by null. So unless and until you get the pointer as null, till that point you will be displaying the data part or the info part of that particular node. This is for inserting the element at the beginning. For inserting the element at the beginning, we need to get the start position obviously. First thing is to create the node, that is allocating a space. Then you are simply checking whether the space is available or not. If it is available, in that case, simply create a new node, and then you are checking if it's an empty linked list or not. Okay, if it is so, this would be the first node, and if it is not the case, you're going to reach to the uh, first node, and that you will get through the start pointer, and there you are going to place your new node, which we have taken a variable over here as a temp for the new node. For inserting at the end, you have to reach to the last node, and that would be obviously will get using the pointer whose value is equal to null. Okay, so if it is so, then you're going to simply place your node over there by moving through the pointer. The same thing that we have done for uh, reaching to the last node. For inserting at a specified position, you need to get the position from the user. So we are getting it from the user over here, and once you have got the position, then accordingly you can reach to that particular position using this particular for loop. So for I is equal to 0, for pointer is equal to start, we have to obviously start from the first node using the start pointer, and unless and until you are getting I is less than equal to position -1, which is given by the user, because we always start with 0, so it's position -1. Until that point you are moving to the next pointers. So once you got the position, there you are going to fix your node. Again, for deleting, you are going to check whether you are trying to delete a node from the empty list or not, and if it is not so, then in such a case you are just checking the positions of the start pointer and so on. So you are going to start with the first pointer, that is start pointer with the first node. Okay, and you are going to reach to that particular node, which you have to for the beginning, obviously your start is pointing to that particular node. So once you have got that node, you are going to delete it, and then you are going to fix the pointer, and then you are going to free up the pointer which you have taken just to get the position of the start. For deleting the node at the end, you have to reach to the last node, and which you will get using the pointer whose value would be null. And if you have got that particular thing, obviously you are going to check whether it is first node or not. If it's so, then your linked list would be empty, and if it is not the case, you have to reach to the last node, and then you are going to fix your pointers accordingly, and then you can delete the node and free up the pointer which you have taken to move to that particular node. Again, for deleting a particular position, you will be taking a pointer for which you will be checking different position, because the position would be given by the user. Just take it from the user. If the position is 0, indicates it's the starting node which has to be deleted. So in that case, you will get its position using start pointer, and if it is not the first node, in that case you can simply reach to that particular position. Okay, and this is simply to check whether the position is available or not. If it is not so, you can delete that particular node by reaching to that position, and then you can delete it. You can run this program properly, and say for example I'm going for creating a linked list, so I'm just trying to insert the nodes, and if I'm trying to display it, so my choice would be 2. So you can see that it can properly display my 2 elements. Again, I would go for, let's say, inserting at the beginning.